Welcome to Combining Functions Algebraically. In the last lesson, we looked at combining functions graphically, but we can also do this by just looking at the equation of each function. So first, we're going to find the domain and range of our first example. And if we know the domain and range of each f of x and g of x, then we can find the domain and range of its combined function. So for f of x, our domain is going to be from 0, because we can't have any negative numbers in our square root sign. Then after that, we can insert any number larger than 0. Has to be positive. Then for your range, because we're inserting 0, our smallest y value will also be 0, and then from there our numbers get larger. For g of x, we have a linear graph, and this is continuous everywhere, so our domain is negative infinity to positive infinity, and so is our range. The first thing we're going to do is determine f of x minus g of x. Another way to write this for the notation is bracket f minus g bracket of x. This is the equivalent of f of x minus g of x. We're just going to subtract the two functions. Remember to write the f of x first and include brackets when you're subtracting g of x. Then we can go ahead and simplify this a bit. And that would be our function for the combined function. Now to find our domain, we have to think about what numbers can we put into this function and it would be okay. Because we have a square root sign, we cannot put in any negative numbers. So the smallest number we can insert would be 0. And then after that, we can insert any other positive number. So that is our domain. Let's think about our range. So for our range, if I were to insert 0 from our domain into this function, I'm going to get 0 minus 0 plus 3. So that means that 3 is one of our limitations in our range. I can write it like this for now. If I insert a really large number now, in place of infinity, into this, we just need to know if it's going to be very large, if it's tending towards a certain number. If we have the root of infinity minus infinity plus 3, because we have a negative large number in the middle term, that means our overall range is going to tend towards that negative large number. So then the other one would be negative infinity. But I have to make sure I reverse the order. So our actual answer is negative infinity to 3, and we include 3. Now we'll determine f of x times g of x. Another way you could see the notation for this is f of x g of x, or you could see it as f dot g of x. More commonly, it's going to look like this one here though, because it does get confusing in case they're talking about composite functions. But just take a note of the different notations. So I'm going to write f of x down first, and then we're going to multiply by g of x. Make sure to include the brackets. Then we can expand. And that would be our final function. For our domain, very similar to part B, we cannot insert any negative numbers into our square root sign, so our limitation is no negative numbers. So we can insert any number from 0 onto infinity. Then for your range. Now to find the range, it is tempting, just like before, to insert the 0 into here and insert a really large number into our function and see what it seems to tend towards. You do sometimes need to be careful about this. If we insert the 0 into our function, we're going to get 0 as the bottom part of our range. But what happens if we insert x equals 1? If we did that, we're going to get 1 minus 3, which means that our lowest is going to be -2 for our y value instead of 0. Then I would suggest trying maybe another number like 2. If we insert a 2 in here, we're going to get something that looks like this. And this number is slightly larger than -2. So it seems like we're tending toward to go back up. So that means -2 is actually our lowest y value. Say this is for x equals 1, and we were able to get the lowest bound here. And if we insert a really large number, let's say 100, then we have 100 root 100 minus 3 root 100. This yields a positive number. And the larger our x values gets, the larger that number gets as well. So our overall range looks like it's going to be from -2 to infinity. Most likely in the final exam, in the provincial exam, they are going to ask for maybe the domain, but the range they may not ask. Most likely they won't, because it is harder to find sometimes. Just like in this last example, like how would you know that you need to figure out it's going to be x equals 1 would give us the lowest y value. And that's why they don't really put that on the exam, just mainly the domain. So I want you to try the next one on your own. Same sort of thing, find the domain and range of each function first, then find the combined function and its domain and range. When you're ready, please press play for the solution. Here's the solution to that, try it yourself. So the domain and range for f of x is going to be -infinity to +infinity because it is continuous everywhere. Then g of x is the absolute value function. We can insert any x we want into the absolute value function, which is why we have a domain of -infinity to +infinity. But for our range, it's going to be from 0 to infinity because we get no negative numbers after we insert any x value. Then for part B, we want to find f of x plus g of x, which is going to be x plus 2 plus the absolute value of x. We can insert any x value in for that, so that's why your domain is -infinity to +infinity. For your range, if we insert a negative number, we are going to get, now if you try to find the range, it's going to be from 2 to infinity. Because if we insert a negative number into our f of x plus g of x, the negative x value from the first term and the positive value in the very last term are going to cancel out, so you're going to be left with just 2. So for example, if you want to see this on the side with actual numbers, let's say we had -100 plus 2 plus the absolute value of -100. This turns into +100, so +100 minus 100 is gone and just left with 2. And that's going to continue on every time you have a negative number. Also, when x is 0, you're just left with 2 as well, which is why the lower bound is 2 and we include it. And then from there, if we insert a positive x value, we're just going to go towards infinity. Now looking at part C, f of x times g of x, we're going to get x absolute value x plus 2 absolute value of x. So we can insert any x value, which is why so that means our range is going to be from -infinity to +infinity because this is going to be a large negative number. And then on the other side, if we insert a really large x value that's positive, we're going to just tend towards +infinity. In example 2, we're going to find the domain and range of each function, but we're going to find f of x over g of x. So your domain for f of x is from 0 to infinity because we can't have any negative numbers, and your range is also from 0 to infinity. Then for g of x, we have a parabola here, so your domain could be anything, but your range is going to start from 0 to infinity. Now, looking at f of x over g of x, your f of x is the root of x, the g of x is x minus 3 squared. If you look at the domain, we get a vertical asymptote here at x equals 3. So we can't include x equals 3 in our domain. And also, from here, we can't have negative numbers. So then our domain is going to then start from 0 all the way up to 3, and we can't include 3 because that's a vertical asymptote, and then from 3 on to infinity. Looking at our range, this will be from 0 to infinity. In example 3, we're going to work backwards this time. We're given the final function and we want to break it into parts such as f of x, g of x, and n of x. If we're just going to add them up together, we can just say that each term is one function. So we can say that f of x is x squared, g of x is negative 2x, and h of x, or sorry, will be n of x, is 3. You can interchange these, so g of x could also be x squared, f of x could be 3, and so on. For the next one, it's just saying find in 2 functions now instead of 3. That means you can combine some of your terms, so this could be f of x, and this whole thing could be g of x. In example 4, we are doing the same sort of thing, but instead of adding or subtracting to find your original functions, f of x and g of x, we're going to find it for multiplication and division. So for this p of x, we're just going to factor this. Factors of 8 is 4 and 2. We want a negative 2 in our middle term, so that'll be a negative 4 plus 2 to give us a negative 2x. So that means one of these in the brackets, let's say x minus 4 can be f of x, and then g of x can be x plus 2. Again, they are interchangeable. G of x could be x minus 4, and f of x could be x plus 2. For b, we have to be very careful about this to find our f of x and g of x, because there's a restriction for g of x. G of x cannot be undefined at any point. So that means your domain in g of x has to be from negative infinity to positive infinity, because if that's not true, we're going to have a problem here. And we don't want g of x ever to be 0. So I'm just going to say that your domain of q of x is x minus 4 is negative infinity to positive infinity, because it's a linear function, which means that the domain of f of x and g of x has to be that as well. And also, your g of x can never be 0, or else we can't divide by it. So that means we need to choose a g of x so it's never 0. And it also has to have the domain negative infinity to positive infinity. So g of x can maybe be a parabola, because this parabola can never equal to 0. Also, the domain of this parabola is from negative infinity to positive infinity. So if I'm going to state that as my g of x, I do need to find f of x. So here's our q of x, and it's supposed to be f of x over g of x, and I just said my g of x is x squared plus 1. In order for this to work out, then f of x has to be x minus 4 has to be x minus 4 times x squared plus 1. So your x squared plus 1 could cancel out and you're just left with x minus 4. So I'm now going to replace this f of x with what I just stated it's going to be. And if this occurs, we can cancel these two out and we're just left with x minus 4, which is what we wanted for q of x. So then your answer is g of x is equal to x squared plus 1, and f of x is x minus 4 times x squared plus 1. Now I want you to try this on the next page on that try it yourself. So for A, I want you to factor it and then find your f of x and g of x. And then in B, I want you to find your f of x and g of x, knowing that g of x has to be never 0 and needs to have the domain the same as your q of x. So go ahead and try that, and then when you're ready, press play. So here's the solution to that try it yourself. Once you factor x squared minus 9, that's x plus 3 times x minus 3. So you can pick x plus 3 as either your f of x or g of x, and then x minus 3 as the other one. For q of x is equal to x plus 1 is very similar to the last one. I just used the same g of x, x squared plus 1. You could have picked x squared plus 2, x squared plus 3. Make sure it's just x squared plus something, because if you do x squared minus something, you will have that function be 0 at some point. So if g of x is x squared plus 1 in this case, then my f of x is going to be x plus 1 times x squared plus 1. And once I show my work here, you can see that x squared plus 1 cancels out and we're left with x plus 1 as our final function.